If not question, the next report, welcome Andrei Grechov, Vladimir Harchenko, and Vasil Kondratyuk. I'm glad to see you, my colleagues from National Aviation University, and the report about communication adaptation using artificial intelligence. Welcome, please. Andrei Mikhailovich.
Good afternoon, colleagues.
Good
I start my presentation. Our presentation.
Started, please. Presentation.
The aim of our report is unmanned aerial vehicle communication channel adaptation using artificial intelligence. Harchenko, Grechov, Kondratyuk. National Aviation University, Kyiv, Ukraine. Communication links in unmanned aerial vehicle network include satellite relay, GNSS channel, ground control station, mobile ground station, inter-unmanned aerial vehicles link, satellite link. The aim of this report is to build model of ground control station stratospheric repeater unmanned aerial vehicle channel using MATLAB Simulink software and to obtain and analyze dependencies of bit error rate on signal noise rate for different data rates. To write program code predicting bit error rate for given signal noise rate and data rate. To prepare artificial intelligence trained model for channel adaptation. To propose block diagram of unmanned aerial vehicle adaptive channel with artificial intelligence. Relevance of the topic. This topic was chosen because in the existing literature there is no quantitative information about data traffic, ground control station, stratospheric repeater, unmanned aerial vehicle channel. In general, there are no theoretical studies developing methods for predictive analysis of stratospheric repeater unmanned aerial vehicle relay behavior. Channel model. Model is based on wireless local area network demo example from MATLAB Simulink. Consists of ground control station transmitter, stratospheric repeater, unmanned aerial vehicle receiver, and additive wide Gaussian noise channels. In our model, we consider the case of channels without fading. On this slide, ground control station, stratospheric repeater, unmanned aerial vehicle link is presented. You can see here ground control station, stratospheric repeater, unmanned aerial vehicle, and channels. Model description. Original stratospheric repeater consists of antenna amplifier, low frequency amplifier, phase frequency shift unit, and antenna amplifier. Amplifier block has both linear mode and the ability to simulate nonlinearity. Antenna gain of ground control station and stratospheric repeater was taken equal to 3.1, antenna diameter 0.4 meter. Unmanned aerial vehicle receiver antenna gain was 1.55, antenna diameter 0.2 meter. Here, obtained data rate impact is presented. Diamonds correspond to 2 megabits per second, O to 5.5 megabits per second square to 11 megabits per second. Influence of data rate on bit error rate. In order to transmit data at a higher speed, for a given level of bit errors, it is necessary to increase the signal-to-noise ratio. For example, for a given bit error rate 10 to minus fifth degree, it is necessary to create signal-to-noise ratio minus 7.5 decibel for a data transfer rate of 2 megabits per second. Signal-to-noise rate minus 5.5 at 5.5 megabits and signal-to-noise ratio -3 decibel at 11 megabits per second. Channel adaptation using artificial intelligence. Let us show how to adapt the parameters of data transmission in the unmanned aerial vehicle communication channel using artificial intelligence methods. Each of 3 bit error rate sets is specified in its own signal-to-noise ratio range. Each bit error rate set corresponds to its own data rate. Python code for predicting bit error rate for given signal-to-noise ratio and data rate is shown in the next slide. Let us describe the program operation. On this slide, code predicting bit error rate for given signal-to-noise ratio and data rate is given on this slide. And you can see that this program is very short. Let us consider channel adaptation using artificial intelligence. At the first stage, data are prepared for data rate 11 megabits, range of signal to noise ratio and values, and the same for another data rates 5.5 and 2 megabits. In the second stage, data are combined in a signal array X, where each row is a combination of signal-to-noise ratio and data rate. Array Y contains the corresponding bit error rate values. In the third stage, model is trained using program from the Python library for machine learning and loading the linear regression model. Linear regression is used to create a model that takes into account both signal-to-noise rate and data rate to predict bit error rate. The fourth step is to predict the given parameter, which will then be used for channel adaptation. Program takes the signal-noise ratio value and the data rate and predicts the bit error rate based on the trained model. As an example, predicted bit error rate for signal-to-noise ratio -5.5 decibel and data rates 5.5 megabits per second is 7.6 on 10 to -4th degree. On this slide, you can see block diagram of unmanned aerial vehicle adaptive channel with artificial intelligence. And now we'll consider each block of this diagram. Preparation of channel characteristics involves information on several parameters, such as bit error rate, signal-to-noise ratio, data rate, modulation time, power, delay, etc. Based on this, the artificial intelligence model is machine trained in advance and loaded into the unmanned aerial vehicle software. Channel is analyzing in real time using the digital information from unmanned aerial vehicle data bus. In accordance with the embedded algorithm, a control command must be generated to change the data transfer parameters, and the channel parameters must be adapted. Conclusions. Report presents calculation of channel characteristics for unmanned aerial vehicle data transmission via stratospheric drone based on the standard. For the first time, an artificial intelligence trained model for channel adaptation was presented. Obtained dependencies of bit error rate on signal noise ratio for different data rates were used for writing code predicting bit error rate for given signal to noise ratio and data rate. And block diagram for unmanned aerial vehicle adaptive channel with artificial intelligence was proposed. Thank you for attention.
Thank you, Andrei Mikhailovich. Very interesting report.